This is 10.6, which is on the binomial distribution probability. You definitely need to have a graphing calculator to help you with this one. I'll be bringing mine up a couple times here so you can see the keystrokes that we're going to use. In a binomial distribution probability, some type of an experiment or a survey or a poll is going to be taking place. There will be n amount of trials. Typically, you're going to have two possible outcomes. A success versus a failure. It could be a yes versus no. It could be flipping a coin, so it would be heads versus tails. It could be a birth question. What's the probability you could have boy versus girl? But it's usually two possible outcomes. And the probability for the success to happen must be the same every time. There is a formula for calculating the probability of successes. This formula is also in your book. We will be using our calculator to do all of these, so you will not have to be memorizing this formula. You can write it down as well, but we won't be using this as a you have to remember it. We'll be using our calculator keystrokes instead. The formula is a combination NCK times P raised to the K, which is the probability raised to the K, times the leftover probability raised to the n minus k. We will use our calculator. What we're going to be looking for on our calculator is called the distribution button. So we'll be doing second distribution button. We're going to arrow down and look for this phrase. This is item number 10 on your calculator, just so you know what we're looking for. Binom PDF, binomial probability distribution function. We're going to look for that phrase, binom PDF, and then we're going to have to enter in three values, n, p, k. N is the total number we'll be using in the trial. P is the probability, but we have to remember to write the probability as a decimal. And K stands for how many successes we will be looking for. All right, first example we're going to do together is on page 78. This is question number 19. This particular question says, calculate the probability of randomly guessing the given number of correct answers on a 30-question multiple choice exam that has choices A, B, C, and D for each question. A, B, C, and D for each question. Okay. N refers to how many trials we're going to be doing. In this case, it said it was a 30-question multiple choice test. So N refers to 30. P is the probability. Well, if I have 4 choices for multiple choice, A, B, C, D, 1 in 4 chance that I'll pick the right one, that's 1/4, 25%. We need to remember to write that in as a decimal, 0.25. K, if we remember the question, which is, let's see, number 19, says that we're going to get 2 correct. If we're totally guessing, we're only going to get 2 correct. So our K value is 2. We will go to our binomial PDF button. We'll type in, remember it's N, P, K. N is 30, P is 0.25, and K is 2. All right, so let's go to our calculator. We go to second distribution. Now the distribution button is above your VARS button. So we need to go second, right here, distribution. And then what we're gonna do is arrow down. I'm gonna get rid of these 2 things here for you. We're gonna arrow down to number 10. Well, mine actually on my newer calculator happens to be letter A. You need to look for this one. Make sure you have binom PDF listed. If it's a newer calculator, it's going to be choice A. If it's an older calculator, it's probably choice 10. All right, we hit enter. So we're on binomial PDF. We're going to do, I believe, again, it was 30 trials, 30 multiple choice questions. Our p-value was 0.25. Our x value is how many successes we were going to look for, which was 2. And paste. So go ahead and hit enter. There's our equation, binomial PDF, 30, 0.25, 2, and we come up with our answer, 0.00863. 00863. Let's go back to my screen, 00863. Hopefully everybody came up with that particular response. Now we're going to go to example number 3, which is on page 726 in your book. For this particular example, what we want to look for is the entire distribution. We don't want to know just one particular answer. We want to know the answer for all of the choices. So in example 3, it says that according to a survey, 41% of U.S. households have a soccer ball. Suppose you randomly survey 6 households and ask them if they have a soccer ball. So that's that yes or no answer. So we have 41% of households are supposed to have a soccer ball. We're randomly going to choose 6 people, 6 households, and ask them if they have a soccer ball. And then what we want to do is draw a histogram, a chart of our results. So what we're doing is asking 6 people. I'm going to do just the first part of what the original formula would look like. We're going to ask 6 people. Nobody says they have a soccer ball. 6 people, 1 person said they had a soccer ball. 6 people, 2. 6 people, 3 of them said yes. 6 people, 4 said yes. 6 people, 5 said yes. And 6 people, 6 said yes. I need to know this entire distribution. So instead of trying to do this thing 7 times, I could do it in one command on my calculator by just typing in NP. Instead of the specific number of successes for K, I can just do binomial PDF and then just type NP. Our N value, how many households are we surveying? And again, that was 6. And the probability number that they said was 41%, 0.41. So I should be able to go to my calculator and type in binom PDF 6, 0.41, and I should be able to get all of my responses. Let's go back to our calculator. Second distribution. Binom PDF, enter. Okay, now this time we're going to survey 6 people, so we need 6. Our probability, 0.41, and this time we're only looking at getting the entire distribution. So if you have a newer calculator where you see the X value, you want to hit the clear button so it's not going to have any number in there. If you're in one of the older calculators, you're just going to type 6, 0.41 and then close your parenthesis and you should be good to go. So I'll hit enter, paste is enter, and there's what my calculator should look like, 6, 0.41. Now when I hit enter, what happens is we get a big long scroll of answers. Now when you look at these answers, the first number that you see represents 6 when 0 people, nobody said yes that they had a calculator. So what we're going to do is scroll through each of these answers. This is the first answer for nobody said yes. This is the answer for 1 person said yes, and so on. So on your paper, and I already have my answers written down, so I'm going to be able to just go to my other screen here. We're going to type down, or write out the first few of these answers, first few of these decimals. 0.042, I'm going to go back to my screen. When nobody said yes, 0.042. If you hit your arrow button, you're going to start moving over to the right and you're going to see your answers. 0.176, the next one 0.306, and so on. 0.283, 0.146, and so on. And you can write down your responses. Okay, so the first one was 0.042. Then we have 0.176, 0.306, 0.283, 0.148, 0.041, and 0.005. This is the entire distribution. Survey 6 households. These are the responses for each of those 6. Now, what do we want to do with this information? We want to be able to make a histogram. A histogram is a picture of your results. So I want to be able to take my results and make a picture. Your histograms are always an L graph. They're always an L graph in the shape of an L. Going across the bottom is how many outcomes you've had. So we're going to put in our tick marks. We talked to 6 families. Instead of putting your numbers right on the tick mark, you put your number in the middle, because what we're going to be doing is making a bar chart. So the first span would represent nobody saying yes. 1 household said yes, 2, 3, 4, 5, and 6 households all said yes. Now, coming up the left-hand side will be our answers. Now, our answers are always in decimal form. As you can see, our answers are in decimal form. They're never going to get higher than the number 1, because remember, all of your decimals added together should equal 100% or just the number 1. We can look at the highest number we've got here, which is 0.306. So if we kind of go accordingly, I could go 0.1, 0.2, 0.3, 0.4, and then I can make my bars according to this chart. Nobody said yes, 0.04. Now you're going to notice that some of your answers are going to be super small. If this is 0.1, this would be 0.05. I need 0.04, so it's someplace in that range. 0.176 for 1 household. 176 might be about right there. 0.306, just a little bit above the 3. 0.283. 0.148. 5 households is 0.041. And 6 households, 0.005. Hardly even off the graph. And that's your histogram. Now, there's a couple questions that they're going to ask you about a histogram. The first question is, which one is most likely to happen? That's obviously going to be the tallest bar that you've got on your histogram. So if we go back to our picture, which one is the most likely to happen? Right here, that's the tallest bar. So 2 people will say yes. Most likely, 2 families. The second question that they're going to ask you is about the shape of your histogram. Is your histogram symmetric or is it skewed? So if you divide your graph, if you have 6 items, look for the third one. If you divide it in half, what you see on the left side should mirror what you see on the right, or pretty close. So you should have the same types of shapes on the left side as you do on the right side. If that happens, that is called symmetric. If, on the other hand, you look at your graph and it is skewed, so if you look at the halfway mark, again, of however many numbers you've got, if there are 10 trials, look at trial number 5 and then split it in half. If then you look at your bars, and your bars might be like this, way tall on one side versus the other, then that type of a graph is called skewed. So let's go back to our graph. We had 6 trials. 6 trials, 6 cut in half is about 3. So if I look at 3 as my dividing line, can you tell, does this one sort of look symmetric or is this one more skewed? It's pretty close to symmetric. It's not exact. We have these 2 tall bars in the middle, and then they drop off fairly evenly on both sides. If I had to give this a name, I would probably call it symmetric. It isn't obvious skewed, so I would go with symmetric on this one. Okay, I think we're going to do a couple samples from your assignment. This is page 728, question number 11. So if you could look at that question. Calculate the probability of tossing a coin 20 times and getting the given number of heads. 20 times, you're tossing a coin, and we want, in question number 11, we want 2 heads. We're going to go back to our binomial PDF button again. N, P, K. N is total. Probability, you're flipping a coin. What's the chance that you're going to get a heads or a tails is 0.5. And the successes that we want this time is the number 2. Go to your button, binom PDF, and you should be able to type in 20, comma, 0.5, comma, 2. .00018. It probably shows up as an E number on your calculator, 1.8 E negative 4. Remember, E is your calculator's way of saying times 10 to the. So move your decimal over, .00018. And the next one that we want to do together is page 729, number 45C. 45, the chart below shows the distribution of blood types. O, A, B, AB. RH factor is positive or negative for human blood. If at random 10 people donate blood at a blood bank during a certain hour, find the probability of each event. We're doing 45C, and C says that at most 2 people are A. At most 2. At most means that you're going to go up to 2, but not go over 2, which means you could have nobody, you could have 1 person, or you could have 2 people at this particular blood type, which is type O. So it's, let's see, we need nobody, so 0 people have it, 1 person has it, or all 2 people have it. When you have the word or in probability means, remember, you need to add these together. So I need to add these 3 answers together to come up with my total. There is a way that your calculator will do a total for you, and this time we're going to look for the new button, binom CDF. C stands for cumulative. Cumulative means it will add it together for you. So it will take all of the answers up to the number that you're looking for. So we're still going to have NPK. We're still looking at N for our total, and we've got, I believe it was 10 people. So 10 people we're going to give blood. Probability, in this case we're looking for, in part C, type O. 2 people are type O. If you look at your chart, we have an O positive and an O negative. 37% are O positive and 6% are O negative. 37% plus your 6%, 43%. So I need to use 43% as my p-value, 0.43. And then K is 2 people, but it's everything leading up to 2 people. So as long as I go binomial CDF on my calculator, 10.432, it will automatically add these 3 numbers together for me and come up with our total. All right, so let's go to our calculators again. Second distribution. Let me erase this off my screen for you. Okay, binom CDF is what we want this time. Cumulative distribution function. And we said we were going to do 10 trials. 10 people are going to give blood. 0.43. And our X value, our K value, success value is 2. We should be able to go ahead and hit enter, and it's going to add our values together for us. So instead of us having to do this thing 3 times and adding our 3 decimals together, this did it for us, 0.1236. I'll go back to my screen, and my total is 0.1236. Probability that up to 2 people, at most 2 people, have blood type O, 12.36%. Okay, so hopefully you wrote down some of these things in your notebook, write them down in your cheat sheet as well for your final in terms of how to find this on your calculator. You're going to want to remember this, especially when it comes to the end of the year. All right, that's it for section 10.6.